Hello again. In this video we're going to look at two special trig limits, and you've probably have seen them before. If not, well, sit back and enjoy. In the first example you see that we have the limit as x goes to 0 of the sine of x over x. Now if you've seen any of the previous videos on evaluating a limit analytically, you may notice that when you plug 0 in for x in both the numerator and the denominator, that we get an indeterminate form. In other words, the sine of 0 is 0, and then we have 0 in the denominator as well. So really, when we try to evaluate this limit with traditional techniques, we get an indeterminate form. The only problem with this one is you're going to be hard-pressed to manipulate this so that you could put it into a form that you can use direct substitution with. Okay, so just for the sake of introducing this limit, I'm going to evaluate this limit graphically and numerically. So if you look at the calculator here, I have actually two functions in here. We're just going to look at the sine of x over x and the sine of x over x right here. We'll look at this one here in a second. You can see the graph down here. I'll blow it up a little bigger for you. And there it is. Okay, what we're interested in is the limit of the function as x gets really close to 0. So this is a pretty good graph. You can just kind of imagine if x was getting very, very close to 0, what is your y value doing? And it looks like it's getting very close to this value right here. Okay. One thing I want to point out to you that of this function is that 0 is not in the domain of this function. So actually there's a little hole here that you can't really see because our y-axis is filling in that hole. But really you can imagine there's actually a hole right here. Okay, this is the value of 1. So graphically it appears that as x gets close to 0 from the left and the right, that our function value is getting close to both to 1 from both directions. Okay, to solidify that, I'm going to go to my table and I'm just going to plug in values to get close to 0. And again, neither of the things that I'm doing right now are conclusive proof that the limit of this thing is 1. Okay, it's just giving us evidence, it's giving us an idea of what it is. Okay, this is interesting here. Look at this. When we're at 0.1, we go to 0.998. When we get closer to 0, we get closer to 1. And then it looks like when we're at 1/1000th to the right of 0, it says that we're actually getting to 1. And what you have to understand here is there's a little bit of rounding error here. There's the calculator here is just simply taking this number, which happens to be very close to 1, and it's rounding it up. That's how it's spitting it out. So you need to be a little bit careful when you're looking at your calculator doing these things. Okay, if we jump to the left-hand side, you're going to see some similar results. Okay, we get this 1 down here, just understanding that we're not really getting mapped to 1 when x is this value. It's just a little bit of calculator error there that we're seeing. Okay, so this limit then, just based on the graph and the numerical analysis, tells us that that limit is 1. Okay, jumping back, let's go ahead and look at the second example here. And again, one thing you'll notice is that when you substitute 0 in for x and x here, the cosine of 0 is positive 1. 1 minus 1 is 0, and we get 0 in the denominator. This once again is our indeterminate form, but again, you may be tempted to try to manipulate this to get it to something that you can use direct substitution on, but again, you're gonna be hard pressed to find that function. Okay, so we're just going to look at this from a graphical and a numerical perspective right now. Let me turn off the other function and turn on this function. You can see everything updated right here, and you can see my curve updated right here. So let's first go to the graph. Okay, here's the graph. Now the thing I want you to ask yourself is, what is the domain of this function right here? Is there anything that's in the domain that's not? What is the domain? What's not in the domain? And if we come back here, you'll notice that 0 is not in the domain of this function. So just like the previous sine x over x, we have a little hole right here in our graph that our y-axis kind of covers up. In fact, I think, let's try this here just to see if it actually works. If I go to format here and I actually turn my axes off, that hole may show up. I'm not entirely sure if it will or not, but I guess we'll see. Okay, and it did. So we removed our axes, and you can see that the calculator quite literally doesn't know what to do here because 0 is not in the domain, so that's not a point it's going to plot. It just doesn't show up in our graph because the axis gets in the way. Okay. Alright, so now if we approach 0 from the left, it appears that our function value is approaching 0. And if we approach 0 from the right, it appears our function value is approaching 0 as well. So the graph would suggest that the limit of this function is 0 as x goes to 0. Okay, looking at the table, my value's already plugged in here, and you can see that the closer that I get to 0 from the right, in this case this is from the right, that this function value is getting very close to 0. This notation right here seems to always confuse people, the 5, the e, and a -4 after that. That's the calculator's version of scientific notation, and this should be read as 5 times 10 to the -4th. That's a really small number. It's smaller than this guy. So we know that this is pretty close to 0. And you can see the same thing going on here. Okay, so this second limit then is equal to 0, at least from the graphical analysis and the numerical analysis. That's all we care about right now. We can prove those limits using some other techniques. For right now, though, let's just rely on our graph and our numerical analysis that suggests that the limit is 1 and 0. Now, in the next video, we're going to look at some examples that specifically use these two special limits within some other functions. So that's the next video. Hope to see you there.